everyone, we're going to use the binomial series to expand the function as a power series. We're also going to state the radius of convergence. So here's your binomial series, and we want to write it in this format so we can expand it. So we're going to write it as the cube root. Well, I'm going to write this to the power of 1/3. All right. And then write this part as 8 times 1 plus x divided by 8. All right. When you take the cube root of 8, you get 2. So this is going to be 2 times 1 plus x divided by 8 to the power of 1/3. So now I can write it in this format as a sum, and I can pull out the 2, and it's going to be the sum from n equals 0 to infinity. My k is 1/3, and then you put n. And then my x to the power of n is going to be x divided by 8 to the power of n. All right, so let's expand this. This is going to give me equals 2. And for the first part, this is our first term, a sub 0, because we're starting at 0. We'll get 1 plus our next term, which is be a sub 1. That's going to be 1/3 times x divided by 8. All right, and then that's just the k times x. And then you're going to have your next term, which is a sub 2, and that's going to be right here. That's going to be 1/3 times 1/3 minus 1 is negative 2/3. And that's over 2 factorial times x divided by 8. And then it's square for that part. And let's do it one more time. Plus 1/3. Then we have the negative 2/3. And then negative 2/3 minus 1 is negative 5/3. Divided by 3 factorial. And then we're going to get x divided by 8 to the, that's cube. And then we have plus dot, dot, dot. And then we close it up. I know it's kind of tight in there. All right. From there, what we're going to do is pull out 2. I'm going to pull this out. Well, let's don't skip steps. Okay, so we're going to write 2 times 1 plus, this is going to be 1 divided by 24x plus, now I'm going to write the sum here because I have a pattern, but we're starting at a sub 2. So this is going to be n equal 2 to infinity. Now we're going to have negative 1 to the power of n minus 1. All right, and then, because that's negatives here, you're going to have times 2 times, next one would be 5. The next one you keep adding 3 would be 2 plus 3 is 5. 5 plus 3 would be 8. If you want to keep going on, we didn't, so dot, dot, dot. And so for your pattern here, let's look. You're plugging, we're going by 3, so this is going to be 3n. This was your second term. So to get the 2, you have 3 times 2, and that's 6. So to get a 2 here, we're going to have to subtract 4. So it's going to be minus 4. All right. Now, for our denominator, let's look at that. We have an 8 here. So this is going to be all over 3n, because we have keep having this 1/3. So that's, you can put that 3 in the denominator. 3 to the power of n. We also have 8 to the power of n right here. And then we have these factorials. So that's n factorial. All right. And this is all times x to the power of n. I know I'm trying to squeeze this all in. Now let's go ahead and simplify this further. So this is so you can see it better. This is going to be, if I multiply through by the 2, I'm going to get 2 plus 1 12th times x plus 2 times the sum n equals 2 to infinity. Basically, I'm just copying everything down that I had before, but you can see it better. 2 times 5 times dot dot dot. And then we had 3n minus 4 for our pattern here, since we're starting at 2. And then that was divided by, and we had 3 to the nth power times 8 to the nth power, which can be written as 3 times 8 to the nth power. So that's going to be 24 to the nth power times n factorial, and then we have x to the power of n here at the end. So that is your expansion. Now for the radius of convergence, remember we had x divided by 8. Remember we had this 2 times 1 plus x divided by 8 to the power of 1/3. So you're looking at this x here. So this has to be less than 1 for it to converge. So that means the absolute value of x has to be less than 8. So your radius of convergence is 8. Thank you. Have a nice day. Bye-bye.